So next, we look at some of the fundamental knowledge of thermodynamics. If you look at the thermodynamics words, it's actually a combination of two Latin words. One is thermo, means heat. Another one is dynamic, means power. Or you can also think that dynamic is something flowing in English, right? So we can link with heat. Heat can be affected by the temperature and the work and energy. So basically, there are relationship between heat, temperature, and work and energy for this thermodynamic subject. So there are three laws for thermodynamic. The first one is the zero law states that if two systems are in thermal equilibrium with a third system, they are also in thermal equilibrium with each other. So for example, I bring two glasses of milk. One is cold, one is warm. When we put it in the room temperature, the cold one will have equilibrium with the room temperature and turn to room temperature. For the warm milk, will do the same thing. So we are very commonly use this to, for example, defrost our frozen meat and so on. So for the first law of thermodynamic, I'm sure all of you can memorize it. It can be energy is a principle of conservation of energy, can be transformed, changed from one form to another, but cannot be created or destroyed. So this is about the changes. If we check with the changes in internal energy of a system, it's equal to the heat added to the system minus the work done by the system. So if we look at this, the yellow part, assume that this is the whole system, okay? So the total of the changes of the heat in the system minus the changes of the work in the system. So they are the total changes in internal energy. But there is no direction for the first law of thermodynamics. So next, besides of first law and zero law, you also learn about the system. System, you need to know about the boundary of the system and the surrounding. So for open system, it's also the same. You have to specify the boundary. Why this? Imagine that you have a huge power plant. You need to focus one system, for example, in this case, a turbine, so that you can calculate and further check on the system based using the thermodynamic knowledge. Whereas for the closed system like piston, so for example, this is a piston, this is the surrounding is the outside of the piston, and the closed system, the inside is the system that we are focused on. So as I mentioned, we know that the energy cannot be destroyed, can be transferred from one form to another. For example, work, kinetic energy, and then move to potential energy, flow energy, internal energy. It can be moved to a different way. And you also learn about perfect gas. You not remember what is perfect gas is a gas at a very low pressure and at temperature of negative 273 Celsius or 0 Kelvin. Okay, the vapor of the fluid tends to obey PV equals to RT, or PV over T equals to R, where R is constant. You also learn about specific heat capacity, amount of heat required to raise temperature of 1 kilogram by 1 degree. So the equation that you normally use, quite familiar with, is Q equals to MC. Delta T is the changes of the temperature. So you also learn about heat. Heat is a form of energy transfer from one body to another body from high temperature to low temperature until to be in thermal equilibrium. So for example, I think it's quite essential for you to know that in which condition your heat is positive, your heat is negative. For example, when you supply heat to the system gains heat. So it's positive. The system gained heat. So after 3 hours, it go to equilibrium. So the temperature of the system is 25 degrees Celsius. In other words, means the heat rejected discharge from the system. So the heat is negative because it's rejected. So you have to remember on this part. I remember some of your senior quite always confused about it, and it will affect your calculation. And you also learn about work. When we talk about work, we remember that the work is a force. You have the force plus the density. So when your system is doing the work, okay, so it's negative because you're losing something. It's working. When you work, you sweat. Imagine you work, you sweat. So you're losing some energy. So it's negative. But if you try to push the system on the graph, pick the slide on the right side. So we are pushing the work input to the system. So the work onto the system. So it's positive. So let's move to the second law of thermodynamics. So the second law of the thermodynamics, I would say it's more to direction. Okay, so let's look at this slide first. Without obey of first law and second law, the process won't happen. So what that means? Means that if you look at this picture, the process is just like a circuit. If you obey the first law, but you not obey the second law, you won't work. For example, a cup of hot coffee does not get hotter in the cooler room temperature. Okay, so for example, a light bulb. Okay, when you on the light bulb for a certain hour, you try to touch it or you try to measure the temperature on the surface. Use the UV thermometer, and you realize that the temperature of the light bulb is gaining temperature. So can I use the candle to heat the light bulb and light the light bulb using this way? No, because you are not following the direction. It cannot occur if you not obey the second law. For example, you transfer the heat to a wire will not generate electricity. In fact, you are generate more resistance for the circuit. These processes cannot occur even though they are not in violation of the first law. But you are not following the second law, so you are not, a process must be satisfied both first and second law thermodynamic to proceed. So you have to identify the direction of the process, also the quantity and the quality. So you also learn about heat engine. Heat engine is the devices that convert heat to work. That's a simple one. So first, if you look at the picture on your left bottom part, they receive heat from high temperature source. For example, solar, oil, nuclear, and then they convert part of the heat to work. Okay, so and then they reject remaining waste heat to lower temperature sink. They operate on a cycle. So if you obey these 4 rules, you are having a heat engine. Heat engine and other cyclic device usually involve a fluid and from which heat transfer while undergoing a cycle. This fluid called working fluid. Okay, so and next we are going to touch about the enthalpy. I'm sure you learned about enthalpy and entropy last. Okay, this is one of the example of table A4, which is thermodynamic table, saturated water temperature table. I'm sure you are quite familiar with this. There are 4 things you can refer and get the value from this table: specific volume, internal energy, enthalpy, and entropy. So what are those? I will generally give you an explanation, and then after that, I will further discuss on how to get it, what is the definition of the enthalpy, entropy, And next part will be some of the important terms and calculation equation for applied thermodynamics. Okay, just now when we refer to the table, there are 4 things we can refer to: specific volume, internal energy, entropy, and enthalpy. So specific volume is the total mass, the total volume over the mass. So in other words, when you look at the unit is m cubed over kg. Or if you look properly, it's actually a reverse of density, because density is m over the volume. So I also can write as the density equals to 1 over specific volume. Okay, for specific weight is weight over the total volume. Okay, so the weight is mg. So the m is, if we refer to this equation, right, it's density over mass over the total of volume. Okay, so when we look clearly in this equation, and then we can use volume, move here, we have the m. So when our m replace with the density over total of volume, and plus g, and this is the v. So we can further cut this, and then we can have density and g. So also, we also know that density is equal to 1 over specific volume. So we can have g over specific volume. We also can do that. Okay? Okay, so for the internal energy is the internal molecule energy in the system. So this is actually only changed due to the temperature change. For example, I try to give some heat on it, the molecule in the system will move very, very fast and jump around. So then you can have a very high and internal energy. So entropy is measuring the disorder part. I will further expand on this part. For the enthalpy is actually means the total measurement of heat in a system. So in this part, the enthalpy not only affected by the internal energy, is also affected by the pressure. When you press the system, the pressure will increase, and also the enthalpy will increase. So also in this, in other words, enthalpy H is internal energy plus the pressure and the total volume. So by using this, you're able to calculate the enthalpy. So now you understand what is specific volume, internal energy, enthalpy, and entropy. So let's go back to the slide just now. So enthalpy is described, energy is taken from a substance to change one from another. So like I mentioned to you, it can be in form of internal energy plus the pressure. Entropy is deal with the disorder of the particle. So what is that means is, let me look at this. So the positive delta S indicate the decrease in orderness of the system. Your molecule is organized, is in very order, neat. For the liquid, they have some energy. So it's not that order. For the gas, is they're moving way far. Can you see that? So when your molecule is moving very fast, means your delta S is positive, okay? In short, enthalpy look at the energy needed, whereas the entropy look at the organization of the particles themselves. You might question, why I need to learn about this? Then we can further discuss on less. And when you go to the apply the more application, then you will much easier for you to understand. So next, your question might be, what happened when entropy increase? So it's not only because of the disorder, it's also because of the temperature increase. So, okay. So if you look at the picture, this is some of the entropy and versus temperature picture. So entropy is quite very important. You can find about the enthalpy. You even can determine the temperature in the process and the properties of the gas. So this is some of the temperature, entropy, and entropy diagram for water. I'm sure you learned this before, okay? So I will further explain to you when we need it next class.